Very good afternoon all of you. So today we will discuss about question ID 890. Okay, question ID 90. So firstly you can see here there is the allylic alcohol and other one is CH2I2. This is called Simmons Smith reagent, right? Simmons reagent, and other one is HbF4, right? So as you know, first step is Simmons Smith reactions, right? What is the characteristic for this reactions, right? So this reaction is goes through the stereospecific as well as stereoselective reagent, right? Selective reactions, right? What is the means of stereospecific? The carbinoid is add to the singlet form, right? Carbinoid add to the singlet form to the alkene, as well as stereospecific. What is the mean of stereospecific? Means that the product cyclopropane retains the geometry of the alkenes. Okay, this is the reactant, okay, and the product will be find out with the retains of geometry of alkenes, right? And as well as the stereoselective reactions. Okay, the carbinoid adds to the same phase of the OH group or hydroxyl groups, right? Suppose that if your OH group is below the plane, then the cyclopropanation add to the below the plane. Okay, like this is the dash or below the plane. So okay, what is the reaction between these two reagent? Okay, so this is your CH2I over CH2I2 zinc and copper, right? So right, or we can say right here X means your halide or CH2 group, right? So generally here we write X. Okay, right, and this part is your nucleophile part. Okay, and this is your leaving group. So we will apply for this, right? Yeah, okay. Right, now you can see here there your allylic alcohol is below the plane, then the product always, the cyclopropanation always same side of the OH group, right? Okay, like this is your below the plane. Okay, this is your alcohol present on the below the plane, and the cyclopropanation occurs in the below the plane, or we can say the same side, same face of the OH group. Okay, then this group goes to the above the plane, right? Okay, why because two positions are available for this reagent. One is below the plane and other one is the below above the plane, right? So okay, I draw just one another example. Okay, same reagent for this reaction, so we will find out the product like this. Okay, because this is the above the plane, so we can find the above the plane cyclopropionation. Right, and this one is the below the plane, so we can get this type of reactant, right? So these are the same stereo have, right? So then the last step for this reaction. Okay, now HBF, right? Okay, so there is a second step for this reactions, right? And this transformation goes through the pinnacle type, special pinnacle type reactions, right? What is the step for this reactions? We will see the next step, right? So यहाँ पे देखें आप, देखो, this gives the proton, right? And there is the other, this have the lone pair, so you can see there, and here are, what is this, strain, right? So this bond over here and this attack minus H2O, and then we will get 5-membered ring. Okay, this is 1, 2, 3 and 4. Right, and this is your hydrogen over hydrogen cis form, and there is your ketone group, right? Yeah, so this example we can take from as-usual, right? Now you can see their mechanism for the original copy, and okay, the option number is C. Option is C for this reactions, right? So thanks for watching this video and subscribe the channel. Please do subscribe the channel and press the bell icon and